Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about inverse Fourier transform from frequency domain to time domain. The inverse Fourier transform is a powerful mathematical tool that allows us to convert the signal from the frequency domain back into the time domain. This process is essential for many applications including signal processing, audio analysis and image reconstruction. Introduction to Fourier transform. Time domain. The time domain represents a signal as a function of time, capturing its amplitude variation. Frequency domain. The frequency domain represents a signal as a sum of sinusoidal wave with different frequencies and amplitudes. Fourier transform. The Fourier transform is a mathematical operation that converts a signal from the time domain to the frequency domain. Understanding inverse Fourier transform. Next. In definition, the inverse Fourier transform is a mathematical operation that converts a signal from the frequency domain back to the time domain. Relationship. The inverse Fourier transform is the inverse operation of the Fourier transform, allowing us to recover the original time domain signal. Importance. The inverse Fourier transform is essential for many applications where the time domain represents of a signal is required. Mathematical representation of inverse Fourier transform. Continuous case. The continuous inverse Fourier transform is defined as an integral over the frequency domain. Discrete case. The discrete inverse Fourier transform is a summation over a finite set of frequencies. Symmetry. The inverse Fourier transform exhibits symmetric properties with the Fourier transform. Computational efficiency. Fast Fourier transform algorithm provide the computational method for the inverse Fourier transform. Continuous versus discrete inverse Fourier transform. Continuous inverse Fourier transform work with the continuous time signal and the entire frequency spectrum representation by an integral equation. Discrete inverse Fourier transform works with the discrete time signal and a finite set of frequencies represented by a summation equation. Practical consideration. The choice between continuous and discrete inverse Fourier transform depends on the nature of the input signal and the available computational resources. Practical example of inverse Fourier transform: audio processing. In inverse Fourier transform is used to reconstruct audio signal from their frequency spectra. In image reconstruction, the inverse Fourier transform is applied in image processing to convert the frequency domain representation back to the spectral domain. In signal analysis, the inverse Fourier transform is crucial for analyzing and interpreting signals in various engineering and scientific disciplines. Visualizing inverse Fourier transform. Frequency domain. The signal is represented in the frequency domain where the different frequency components are identified. Inverse transform. The inverse Fourier transform is applied to convert the signal back to the time domain. Time domain. The resulting time domain signal is now reconstructed, revealing the original waveform. Applications of inverse Fourier transform. Audio processing. It is used in audio synthesis, speech recognition and music signal processing. In image reconstruction, enables image processing techniques like filtering, compression and restoration. In signal analysis, crucial for understanding and interpreting signal in various scientific and engineering fields. In digital communications, plays a key role in transmitting and receiving digital signal in communication systems. Thank you.